So now is when we're really going to start getting into the fun stuff. We're going to start to write code that we can see the output of in our preview window. We're going to be focusing on some basic shapes and also how we can color those shapes and play with the outline of them. So before we do that, I want to go ahead and reset the canvas to the default, which was 400 by 400 pixels. Let's go ahead and run this again so that that updates here. And a majority of the work here is going to be done within the draw function. So once again, setup and draw have two different types of behaviors. For draw, since it runs repeatedly, it runs over and over again, this is where I'm going to be wanting to put all of my shapes, everything that I want to be output into the preview and be visible is what I want to do inside of draw. So let's go ahead and click at the end of the background statement, the very end after the semicolon, and let's press enter a couple times to make some new lines of code. Once again, we want to make sure we are working inside of draw, right? So inside of these curly brackets. If we start to work outside of it, we're going to run into some issues and things are not going to work as planned. So I'm going to be, again, working inside of the draw function. And let's start very small, very minimal, with the point shape or the points thing. A point is, very simply put, a single pixel. And this command actually changes the color of a single pixel. If we recall, the way that a canvas is oriented is that it is essentially a grid of pixels or a coordinate system of pixels. In this case, since our canvas is 400 pixels by 400 pixels, if you do the math on that, that's about 160,000 pixels on our grid. So with a point, we can change the color of one of those single pixels. So for the point function, once again, whenever we have a command in p5, it is going to look similar to this. There's going to be the name of the function, and then in parentheses, the inputs we need to pass in order to give definition to that function or definition to that command. For point, this is we can call it the formula for how point works or how point function works. So we use the keyword point, and then point is going to take two inputs, an x coordinate and a y coordinate. So let's go ahead and do this here. What I want to do is I'm going to use line 8 here. I'm going to type out point. And you'll also see as we type, there is an autofill or auto suggestion that I can use. And also it'll take me to a reference page where it gives me details on how that function works and how to use it. This is a great resource, especially if you need a refresher or just a quick refresher on how these different functions work. Let's go ahead and click on that, and then I'm going to do my open close parentheses. Keep in mind, once you do the left parentheses, it automatically closes. So we really only have to type out one parentheses here. And then let's just go ahead and end that with a semicolon for now. So inside of the parentheses is where I have my inputs. So I'm going to give this a value of 200, comma, 200. So again, this is the x and the y coordinates of my points. So let's go ahead and run this code. And right now, it looks like there has been no change. But I promise there is a change there. It's just very, very small and really, really hard for us to see. Why? Because it is only one pixel that we're changing. The default color of the pixel is black. But if we maybe look closely, maybe you'll be able to get a glimpse of that. But right now, it's kind of just trusting that it's there. We will learn how we can make this larger later on. But for now, that is how a point works. And to actually give you a visual of what a point is, you can see here that it is, again, just a single pixel. Looks like a black dot in this example. And again, it's set at the position that we determine, so the x and y position. In this case, it should be smack dab in the center of our canvas. So go ahead and take this opportunity now to practice drawing some points. I'm going to ask you you can pause the video, draw 4 more points, 1 in each corner of the canvas. So go ahead and give that a shot, and we will be back. Okay, hopefully that went well for you. I'm going to go ahead and do this really quickly here. So I want to draw 4 points, 1 in each corner of the canvas. So I'm going to start off with the origin. So I'm going to draw a point at 0, 0. And then I'm going to draw points at the top right corner of the canvas. In this case, I'm moving along the x-axis all the way to 400, and then I'm staying on the 0 for y. Bottom right, it's going to be points, and then I'm going to stay at 400 and go all the way down to 400 on the y. And then lastly, here I'm going to be in the bottom left corner, so it's going back to 0 for x, and then staying at 400 for y. Great. So that's what it should look like for you. Another reminder, an indicator of this being saved, this notification here, saved just now, puts my mind at ease that my work is being saved. Great, so let's go ahead and move on. Let's talk about something a little bit more exciting. Staying in the realm of pixels and points here, we're going to now look at the line function. So we can think of a line as being a set of pixels or a set of consecutive pixels that span some kind of distance. The command for line is, you guessed it, a line. And line takes in 2 sets of coordinates. The first set is the starting x position and the starting y position. This is signified in our formula as x1, y1. The second set is the ending position, or the ending x and the ending y. So our complete formula, we have 4 values that we need to type out for our line. So the visual output of this formula is going to look something like this, in which we define, once again, a starting position, and we would define an ending position. So the line is going to draw or color the set of pixels that runs in between these 2 points. Let's go ahead and practice this in our editor. So I'm going to use the line function. And what I want to do is I want to create 2 sets of lines, one that runs horizontally across the canvas and one that runs vertically down the middle of the canvas. So this is going to be splitting the canvas evenly in the middle. So my first line, what I want to do is have my starting position, so my x1, my y1, is going to be 0 and 200. Okay, so in this case, I want it to be starting down here at the middle of the height of my canvas. The second set is going to be the ending position of that line, which is going to be all the way over here to the right. So the x is going to be 400, and the y is going to stay the same at 200. So let's go ahead and run this, and we should see our line being drawn on our canvas. It is good practice to continuously run and check your code as you go. This way, if there are any errors that go on, you catch them right away. So the last thing you want to do is write a whole program without running it one time, and then you run it at the very end, and then you're met with all these errors that you have no idea even where to start. So it's good practice as you go, run your code. Our second line is going to be the vertical line that's splitting the canvas vertically. So this one here, I'm going to start with the x1, y1. So this is going to be starting in the top center of my canvas. So that x is going to be 200. The y is going to stay at 0. For the second position, it's going to be at the very bottom of the canvas. So the x is going to stay the same at 200, while the y is going to travel all the way down to 400. Let's go ahead and run this code here. Perfect. So that is how line works. Following this pattern, for line, we define 2 sets of coordinates, a starting and an ending. Our next shape is going to be following the same principles, and this is the triangle. So for a triangle, we define 3 sets of coordinates, right? A triangle has 3 points to it, and that is how a triangle is defined. That's how it is drawn in P5. So with the triangle, 3 sets of coordinates, you'll see that our inputs are getting much larger now. There's a lot more going on. But again, just think of this as 3 sets, an x1, a y1, all the way to x3 and a y3. So here is an example of how the triangle could be drawn. So I will give you caution when you are using triangles that it is important to first map out the coordinates on like a scrap piece of paper, only because if you are to start to mix the coordinates up and things aren't lining up correctly, your triangle may come out as a line or it may come out as some kind of inverted shape. Word of caution when you are using triangles, just be extra careful about planning this out and where this is going to be on your canvas. So let's go ahead and draw a triangle here for ourselves. I'm going to go below line next, and now I'm going to type out the command. I'm going to be following the formula, so triangle. And you'll also see that P5 is very generous, and it also gives us the inputs that it requires of this function. So I'm going to end that with a semicolon in first. So triangle, I'm going to already have one mapped out for us, so we don't have to sit here and troubleshoot together, although that would be really a fun learning opportunity. But my first position is going to be 25 and 35. This is my x1 and my y1. My second is going to be 45 and 65. And then my third is going to be 45 and then 25. So let's go ahead and run this. And uh-oh, we have a syntax error. So I pressed play and now my preview disappeared. The program crashed. What do I do? So let's take a look at the bottom console here where I see this red text. For the console, you can pull this up to see more of it. If you hover over this panel here, you can click and drag up. You can also expand the message here as well. So the error I'm getting is a syntax error, and it says I'm missing a parentheses. It also gives me the line of where that error is happening. So this is occurring on line number 17, and it's also highlighted it for me as well. So although P5 is good at catching the errors, sometimes it's not that good at seeing what the error is. In this case, what I did was I missed a comma. So I can visually see and check that as well. It's always also a great idea if you are spending a lot of time trying to find what you did wrong to get someone else's input. It's always great to have someone to send the code to. We have the Slack that you can post your code in as well so that we can get more eyes on it and really see what's happening. You'll be surprised how quickly a fresh pair of eyes can spot the error. Then, sometimes I'll spend a good 5 minutes trying to figure out what I did when it's just a comma. So after 65, I missed that comma, so I'm going to add that comma back in. Let's go ahead and press play. And now things are back to normal. My canvas is drawn, and I see my triangle being drawn where I wanted it to be. Great. Moving on forward now, let's once again follow the same pattern. So a line needs 2 sets of coordinates. A triangle needs 3 sets of coordinates. Our next shape is a quad. So a quad is going to require 4 sets of coordinates. A quad is 4 points that are all connected together. So in this case, this is probably one of the longest shapes. The shapes with the longest inputs we're going to have is the quad. And so this is an example of what the quad could look like. It's great with the quad because we can really get very detailed about the type of shape we create with the quad. So for our example, let's just go ahead and practice this last long one here. So I'm going to use the quad keyword, the quad function, and I'm going to map out 4 sets of coordinates. So the first one is going to be 125, 135. The second point is going to be 165, comma 170. The third point is going to be 150 by 115. And the last point is going to be 125 by 150. So let's go ahead and run this here. And you'll see now I have my shape, but now it doesn't look like a quad. It looks interesting, but what I was going for was more of a rectangular shape, right? So this is another example of what happens if you do not map out your points prior, especially with these more complex inputs, these more complex types of inputs that we're using. So all I'm going to do here is I'm just going to go ahead and we can keep it if you want. I don't want to keep it. I kind of want to have a regular quad. So I'm going to go ahead and delete these points here, just the points inside. I'm going to redo this. This time I'm going to use a different order. So I'm going to have my first set of coordinates are going to be 125, comma 135. My second set is going to be 125 once again, and then 150. My third, 165, comma 170. And my last one is going to be 150, comma 115. So I'm going to run this one more time, and there we go. That quad is looking more like a quad, more of what I had wanted it to look like initially. Let's move on. Let's move on to some more simple functions that we can use to get specific shapes. So the next function is the rectangle. And the keyword or the name of the function we're using is called rect. Rect, similar to what we've already seen, takes a starting x position and a starting y position as its first two inputs. It also takes a third input, which defines the size of the rectangle. So once again, we have the starting coordinate. In this case, this is going to be a bit of a special thing to keep in mind and remember. Whenever we have a rectangle, we have a starting x and y. This point is always going to be on the top left corner of the rectangle. This is similar to how the canvas works and where the origin point is for the canvas. The origin point of the canvas is the top left corner. Same thing for the rectangle. The origin point is the top left corner. So when we define the size, this is going to be all sides, so left to right and top to bottom, right? So we start from the coordinate point, we start from the origin point here, we go over the length of the size, and we go down the length of the size as well. So let's go ahead and try this here in our editor. So make some new lines of code, and I'm going to use the rect keyword. And what I want this to be is at the point 350. And then the size, I'm going to make this 75. So let's go ahead and run that. And there is my rectangle. So a reminder that the units that we are working with are pixels. So when we say 75 here, that means it is 75 pixels wide. Okay, 75 pixels across and 75 pixels up and down. There is an alternate way to define a rectangle. So this alternate way is simply adding a fourth value or a fourth input. So once again, we have the starting position, the x and the y. And in addition to that, in addition to our starting point, we can also define a width and a height. Right, so what we created previously was just a square. Here we can create a true rectangle that has a different width and a different height value. And what that could look like is something like this, where we have a width that is longer than the height. So let's go ahead and create a rectangle of this type in P5. So I'm going to create another rect function here. This starting coordinate is going to be 210, comma 100. And then the width is going to also be 75, but the height, if I add a comma, I can add a fourth value. And this height is going to be 30. Let's end that with a semicolon. Let's hit play. and then we'll see our second rectangle appear next to our square. So this is another great example of the variability of some of these functions. And P5, it knows that it can accept either 3 or 4 inputs, and it knows what to do if it receives either, right? It knows what to do. It still draws us a rectangle, even if we only put 3. If we put 4, it knows that that's a special case, and it knows to adapt appropriately. So this really here is where we're getting into the beauty of P5, in that there are these functions that we can use. They're already defined somewhere else. We don't need to know how they work. We just need to know how to use them. The last shape that works like this is going to be the ellipse. So the ellipse, it works in the same way as a rectangle, or the rect, in that it can either take 3 or it can take 4 inputs. Starting with 3 inputs, we have the x and y position, and then we can also define the size or the diameter of the ellipse. So what this looks like here is something similar to this. The difference with the ellipse is that the center point is in the center of the ellipse, right? The origin point is in the middle. So when we define the starting position of an ellipse, we are defining where the center is going to be. And then the diameter is just the size of that ellipse, the size of it across from one point to the next, or one end to the other end. So let's go ahead and create an ellipse here. So below rect, make some new lines of code. Again, making sure we're inside these curly brackets. I'm going to use my ellipse keyword. And the starting position, I want to be looking at the bottom left quadrant now. The starting position is 50, 100. And then I want the size of this to be 175. And once I hit play, I notice that, I actually did not put it in the bottom left quadrant. It is in the top left quadrant. So what I can just do is I'm going to make this, instead of 100, this is going to be 300. And then let's hit play again, and there it is. So expect to have to adapt and change values like that based on the position, right? If you don't like where the position of a certain object is, then it's just as easy to go in, edit, change the value until you get the place where you want it to be. If we look at the ellipse now that it is drawn, we will notice that it is being cut off. So this is also another great point to keep in mind of P5, is that even though we have a limited drawable area, shapes can still be drawn off of that area. The only issue is that it's not visible, right? It's not being shown, it's not being rendered. So in this case, we kind of get a cut-off ellipse, and this is okay, but just keep that in mind. If you're not being contained within the canvas, then your shapes are not going to be seen, they're not going to be visible. So ellipse also takes 4 values. So we have a x, a y, and then we can also define the width and the height separately. And this is really what makes it a true ellipse, is that it has different varying width and heights. So we can get a shape similar to this if we use 4 values. So let's go ahead and practice this in P5. I'm going to create another ellipse. And this one's going to be at 300, 200. And then the width is going to be 100 pixels wide. The height is going to be 175. And let's hit play. And there is my next ellipse. So if we look at the ellipse, we notice that it is now overlapping with some of the shapes that were already there, right? We see the line is being drawn on top of, as well as the rectangles, right? The ellipse is essentially covering part of these shapes. So with P5, order matters. Order is very important because it works as layers. As we write code and as we move down our program, we are essentially creating layers of shapes. The very first shapes that we draw are the bottom-most layers. So the most recent shapes, or the shapes that we draw towards the end of the draw function, are going to be the topmost layer. So keep this in mind as we're working in P5, is that you are able to overlap shapes and create layers just like this. An example of how we can change this, let's say I don't want the ellipse to be over my rectangles or my line. Let's say I want the ellipse to be behind these shapes. Well, what I could do is I can simply click and drag. I can highlight this line of code, and then I can move it to wherever position I want it to be in my program. So since I want it to be behind my rectangles and behind my line, the position where I have to drag this is going to be before I draw my lines. So in this case, it's going to be above line. For me, it's line number 13. So if you highlight that line of code, make sure you grab all of it. You can click and drag it, and you'll see now my cursor is kind of moving through my program here. I can drop it to where I want it to be located. And now if I hit play, you'll see that order changed, right? The layer has changed. So now my ellipse is behind all my other shapes. And let's go ahead and just clean this up. I like to have spaces in between these different shapes just for the ease of readability. Another quick thing about formatting is notice how within draw there's an indent on each line of code, on each statement. It's going to be important that we are kind of making this consistent as we're writing code. It's just convention, and it's also just easy for us to be able to see and read as we're going down. So if you start having like skewed lines of code like this, that's going to start looking very messy. And it's not really going to be easy, especially when it comes to collaborating with each other, or even myself with grading. This is going to make life a little bit harder, especially when it comes to troubleshooting. So it is important that we are maintaining the indentations here as well. So I'm just going to go ahead and Control Z through that to put those back to where they were. Great, so that is going to be it for shapes for now. The next thing I want to cover is color. So with color, I mentioned towards the beginning of this video the background function. So the background is the very first example of how we can start to play with color on the canvas. Background is a special function. It is responsible for changing the color of the canvas, or in this case, the background color. So by default, the value is 220. So background, since it's taking one single input, works within the grayscale. And the grayscale, as we see here, goes from 0 all the way to 255. 0 being completely black, 255 being completely white. A good way I like to think about this range is that 0 means that all the lights are off, right? There are no lights that are turned on. So if I change the background to 0 and hit play, you'll see now my background on my canvas is completely black. If I were to change this to 255, oops, I didn't want to press enter, 255 and then press play, you'll see now it is completely white. And if I want anything in between, any kind of shade of gray, I can just make this something like 120 and press play. And now I have a bit of more of a dark mode kind of canvas going on. What I'm going to do here is I'm actually going to put ellipse back to where I had initially put it, which is at the very end of draw. So I'll go ahead and click and select ellipse, drag this down. I'm going to drop this at the end of my draw, making sure once again it is inside that draw function still. The next way that we can use color is by using the fill function. So the fill function is more specific to changing the color of shapes. With background, that is more specific to the actual canvas. With fill, we can use this to fill our shapes. So let's go ahead and take a look at how we can change the color of our triangle. Fill also takes a grayscale value. So if I were to type out fill open close parentheses, I can type in one input. This one input is going to be sharing that same grayscale range. So let's, for example, say I wanted to make the fill this 220, and that with a semicolon. So wherever I want to change the color of a shape, I want to make sure I have fill above that shape. Once again, the order matters. So as I move down, P5 is reading each line of code and then executing that code. So what I want to do first before I draw my shape is I want to define the color of that shape, and then I want to draw it. So that's why we're typing this above the triangle shape. So let's go ahead and hit play. And there is a change, right? So we saw the change, it changed to gray. However, it looks like all of the shapes changed, right? So every single shape on my canvas actually changed its color. And this is because fill applies to everything below it. So even though we define it, we put it above the shape we want to color, it is still being recognized as a command that is going to carry out throughout the rest of my draw function. And to demonstrate this, what I'm going to do, I'm going to go into setup actually. I'm going to click my cursor at the end of create canvas. And what I want to do is I want to type out this command. This is noLoop. So make sure we're paying attention to the capitalization. It's lowercase n for no, and then uppercase L for loop. noLoop, open close parentheses, and then a semicolon. So what this does is this actually forces draw to only run one time. And this is just so we can kind of see how fill is working and how the order. I just want to prove to you that order matters. So let's go ahead and move fill. I actually want to make this darker, so I'm going to make this 100. And let's move fill down to be above quad. Okay, so I'm now moving it below the triangle. I'm going to hit play. So now you'll see that because my fill takes place after my triangle is drawn, my triangle is left alone. And all the rest of the shapes are now being colored darker. Let's make fill 50. I just want it to be very clear that this is a thing that it is actually changing. Okay, so there is proof that the order where we put fill is going to affect everything below it and not anything above it. So that is fill, and that is the fill with one value using a numerical value for the grayscale. With fill, we can also use a color. So what I'm going to do is below the quad, I'm going to make a new line just so there's some space there, and I'm going to call fill again. And this time, what I want to do is I want to add single quotations. So we can add single quotations. We can also use double quotations. I'm going to be using single for now. So inside of these single quotations, I'm going to type out the name of whatever color I can think of. I want to use red. And then I'm going to end that with a semicolon. So let's hit play. And now you'll see that everything after this rectangle is now being colored red. And this is a cool trick. If you can think of, whatever colors you can think of, red, blue, green, orange, you can just type out the word here, and that will take the color there. We also know it's recognized because there is a little color box next in front of the word. This also makes a color picker available to us too. So if we want to get a little bit more customized with a color, we can use this box there. A cool resource I want to show you, just to give you more options if you are, for now, more comfortable with using these plain text colors, is the CSS colors page. So this is on the website W3 Schools and is also linked in the tutorial guide for this video. But this gives us a list of colors that we can use within the fill function. So whatever color you see, most of the colors that I've tried here work. I have yet to try one that does not work. For example, let's say I want to use light coral. It's a pretty specific color. I can come over here and maybe instead of, let's actually use fill again for the next rectangle. So above my second rectangle, I can use fill, and let's use in single quotations, let's use light coral. And it looks like it was recognized because once again, that color box appeared. And if I hit run, now we can see that is taking effect. Okay, so for next, what I want you to do is try this on your own. So I'm going to ask you to go ahead and make the rest of the shapes a unique color using fill. You can use either an integer value for the grayscale, or you can use a text value or a CSS color to make it an actual RGB color. So go ahead, pause the video, take some time, change the colors for the rest of these shapes. So this is my final composition. Very, very stunning, if I say so myself. One thing I want to point out is you may have noticed, or maybe you may have tried to change the color of the lines. So if I were to try and attempt this, I'm going to make sure I'm above a line. If I type out fill, and just to make this obvious, let's make this yellow. If I were to try to change the fill for the line of yellow, there's no change. And what actually happens is it ends up changing the fill for the triangle. So it completely skips over the line. The reason for this is because the line has no area. Again, it is strictly a row of pixels, right? There's no in between. There's no area that it can actually fill for the line. So what we can do is use a different technique for changing the color of the line or the points if you wanted to. And this is going to bring us to our next function, which is the stroke function. So stroke is going to change the color of the outline of any shape. In this case, we can use stroke for line, and we'll also see that we can use it for any other shape. So above line, let's go ahead and use the stroke command. And this is very similar to fill. It takes in two types of values. It could be either the single grayscale value, or we can use a text color. So I'm going to use, to make this very clear and obvious, I'm going to use a text color. I'm going to use the yellow once again. And if I hit run, okay, so we have the line, the color of the line changed, but now we can see once again this ripple effect is happening. So everything below line is also being changed to yellow. We can see that line, since they're just a row of pixels, those are all yellow, but then also the borders of the shapes are being changed as well. So for this case, what we can do is once again, we can go through, before each shape, we can set the stroke to a different color value. So go ahead and take some time. I'll do one right now. So I'll work above triangle. I'm going to change the stroke once again. And if you want to reset the stroke, we just type in 0, because 0 is black. So it's just going to change it back to the standard color. But again, you can use any of these single values between 0 to 255. You can also use a text color using that CSS color cheat sheet, or just whatever simple color you can think of. So I'm going to go ahead and hit play to see that the triangle, as well as everything else, has been reset. So once again, the next to-do, the next challenge for you is to either reset or change the stroke for each shape. And as far as position, it could be before or after fill. As long as it is before the actual shape is being drawn, that is what matters. But you can either do it after fill, you can do it before fill, as long as it is above the actual shape. And here is my final composition with those strokes being changed. So the very last function for this video is the strokeWeight function. So we can change the thickness of the borders of our shape using strokeWeight. StrokeWeight only takes one value. It takes one input, and that is the thickness of the border. So I'm going to go ahead and focus on this last and final ellipse here. And after stroke, or anywhere before ellipse is executed, I'm going to type out my command strokeWeight. And it takes in one input, and this is going to be how thick the outline or border is in pixels. So if I were to make this stroke weight something like 3, hit play, you'll see that this final ellipse, you'll see that that border expands and it gets larger. Important thing to note about syntax when it comes to stroke weights. Notice how there are uppercase and lowercase letters. So these functions are case sensitive. So if you were to type this all in lowercase, which I'll demonstrate now, and try to run that, it does not work, right? It does not recognize this as a function. You can see the reference error we get. Stroke weight is not defined. So P5 is very picky. And maybe we've already learned this by now, or maybe we will learn this in the near future. But if we miss an uppercase, if we misspell something, if we miss a letter in one of these functions, then things are not going to work out. P5 is going to freak out. In this case, my ellipse is not even drawn anymore. Okay, so making sure that we are being very meticulous and very careful with when we are typing out these functions and commands is going to be instrumental in a working program. It's going to be required for a working program. So I made that change. Let me go ahead and run this one more time. I see that my last save was 15 minutes ago, so I'm just going to go ahead and do Control S or Command S, make sure that saves. And that is going to do it for this week's tutorial.